If you put a mic in front of a singer and simply record it, or put it straight through your sound reinforcement system, that's what's called a raw, unprocessed signal. But there's lots you can do to both colour and process that signal before the audience actually gets to hear it. You can get rid of unwanted background noise, you can add reverb to it, make it punchier, add some echo, maybe even make it sound like it's been generated by a synthesizer. All such things we tend to lump under the heading of adding effects. Effects are tools. Sometimes you'll find a range of them built into the mixer. Sometimes you'll need to purchase and plug in a specific effects processor. Effects can broadly be divided up into two categories: signal controlling effects and signal processing effects. And in fact, signal processing can be further divided up into special effects and spatial effects. Signal controlling effects are simply used to manage sound. Why does sound need managing? Well, say you want to make a sound more consistent in volume, minimize the peaks and troughs. Effects that squeeze or compress the dynamic range of a signal in order to do this are called compressors. Or perhaps you want to be safe and put an absolute limit on the level of a sound in order to safeguard against overloading, something that could certainly severely damage your equipment. In this case, you would use a limiter. Perhaps there's a bunch of other noise or audio going on around the sound you want to amplify. No problem. There are devices that employ an electronic gate that opens to let your sound through and then closes as soon as it goes below a certain level in order to keep out that background noise. And these are called noise gates. Hey, finally we've come across a whole range of sound reinforcement equipment that actually has names that mean something. Without a compressor, you can always do this. That's right. The job of a compressor is to smooth out inconsistencies in level. And you could, if you're extremely quick, do what's called ride the gain. Alternatively, when it comes to compressing vocals, you could just hope that you have a real pro singer with a great mic technique. An actual compressor is probably a safer bet though. Compressors are connected directly to the channel or signal that you want to compress. The nature of the effect is such that every sound that needs compressing should have its own compressor or compressor channel, because the settings need to be adjusted individually to suit that particular sound. The first adjustment to make is the threshold, the level above which you'd like to hear your sound to be reduced in volume. In effect, this is like an engineer yanking down the fader every time he sees the signal go above a certain point. Okay, but how far down is he yanking that fader? On a compressor, this is stated as ratio. A 2:1 setting will make a 2 dB increase in the sound only increase by 1 dB. This would be called fairly gentle compression. And this would be a good starting point for a vocalist. A 6:1 ratio, on the other hand, will produce considerably greater level squashing. You might use a setting like this with a kick drum to make a punchier sound. So we've seen the when, and by how much. How about the how fast? Depending upon the model, you may also have control over how fast compression is initiated, governed by the attack control, and how fast normal uncompressed levels will resume, governed by the release control. A fast attack is probably best with a vocal, where you want to keep the sound as natural as possible. If you're compressing a kick drum though, you might want a slower attack, so the percussive front end of the sound still has time to be heard before the compression actually kicks in. If a signal seems to be pumping, or you can hear the gain being adjusted by the compressor, your release time is probably too short. These are just the basics of using a compressor. There's a lot more to learn, and a lot of good material out there on the web or in book form to turn you into an expert. If you set a really high ratio on a compressor, say 15:1 or something, you are in effect putting up a brick wall against signal overload, and this is then called limiting. Sometimes a limiter is built into an amp or a powered mixer. You can also find dedicated standalone limiters, and certainly there are quite a few limiter plugins on the market for studio use, but most likely you'll find limiting facilities for live sound on one compressor limiter unit. Compressor limiters are generally connected to an individual channel. Large touring rigs encompass a range of effects from compression and limiting to EQ that would be applied to the mix as a whole. This has a dual function, both as a safeguard against dangerous level spikes that could damage loudspeakers and as a fine-tuning device to tailor a mix for a particular room or setting. Effects for this purpose will be connected in line between your mixer's output and your amplifier's input. Let's face it, playing music at all takes skill. Playing music in front of a live audience throws a whole army of additional problems into the mix, some mechanical, some ergonomic, some just visual. We're talking about extraneous noise, be it mic handling noise, wind at an outdoor gig, bleed from a neighbouring sound source, or even just a squeaky kick drum pedal. All of these can make a mix sound muddy or muffled. This extraneous noise is not something you want in a live mix, and a noise gate will help you get rid of it. Similar to a compressor, a noise gate is connected in line via a channel insert, and has a threshold setting that determines the level below which the gate will close and no sound whatsoever will come out of that channel. So let's take a vocal mic and a general on-stage sound as an example. When the singer is singing, you don't notice it at all. But when they're not singing, you really don't want an open mic on stage. Set the threshold on your gate so that when it is only hearing the indirect stage sound, it'll close down, resulting in total silence on that channel. When the singer starts up again, the threshold will be exceeded and the gate will open back up and let the sound pass. Again, similar to a limiter, you'll generally find control over attack and release, so that the effect can appear to happen naturally. In particular, if the release is too short, then a nice slow fading sustain on a guitar or a trail of a cymbal hit could get cut off abruptly. Signal processing effects actually alter the sound itself. This can either be through spatial effects, where a sound can be made to seem as if it's being played in a range of different spaces, like a stadium or a concert hall, or an echo chamber. Or it can be through the use of a special effect that fundamentally alters the sound itself, like a chorus, flanging, or a dramatic synthesizer pitch effect that you tend to hear on a lot of dance music at the moment. If you're recording, this is a huge area to learn about, but for live sound, this is not quite as pressing a concern, for two reasons. Spatial effects can be crucial in a recording because you want to create an atmosphere in which the music is seemingly taking place. Well, live it is taking place, and the reverberations and reflections that signal processors are recreating for you on record are quite often present and correct because your sound really is bouncing off walls and ceilings in a venue. So adding more reverb may only muddy your sound and make it less intelligible or less easy to understand. As for special effects, these are mainly applied to the sound of a specific instrument or part. So you're off the hook here as well, since the guitarist or keyboard player will probably be capable of, and indeed want to apply, these for themselves. For these reasons, we'll be keeping this part of our voyage of discovery fairly short. The most common spatial effect is reverb. Without any effect, or dry as engineers call it, the vocal is very present, very intimate, but also quite naked and unforgiving. Add reverb to a sound and it seems to be more natural, as it sounds as if it's been sung in an actual environment. It also sounds a bit more polished because you can't distinguish every little fluctuation and deviation in the performance. Now the sound will be called wet with reverb. Vocalists love reverb. Reverb units are generally patched into an aux bus on your mixing desk, so that any channel can share the effect. This way, all the different sources will sound as if they're coming from the same environment, making the sound more natural and believable. While each channel can use different amounts of reverb, it's important to understand that you can only use one setting or patch on the reverb unit at a time. The moral of this story is to look for a setting that will suit a wide variety of sounds. Yamaha has been producing excellent digital reverb units for a great many years now. You can, as many people do, simply flip through the presets and find a general tone of reverb that suits your particular purpose or venue. If you're playing in the Spectrum in Philly, you probably won't need a very long reverb time. The Spectrum Bar and Grill, that only holds 150 people, well, yes, you probably can afford to use longer times to create the illusion of playing in a basketball stadium. Avoid using reverb on sources that don't benefit from the effect. An example would be a bass guitar or a kick drum. These sounds would only be muddied. A good rule is that higher frequency sources like a snare drum, vocals or a cymbal are candidates that would benefit from reverb. Delay effects are actually very closely related to reverb, but where reverbs don't tend to have defined repeats or echoes, that's exactly what you want in a delay. You want the snare to sound and then here in probably decreasing volume and preferably in time with the beat of your song. Some singers use a trademark echo or delay, 1950s slapback echo for instance. And sometimes a song, or even a style of music like Jamaican dub, demand the use of delays. These are perfectly legitimate applications, but in general it's best not to smother your mix with delays, as it can get quite wearing on the ears. Although most special effects like chorus or flanging will be applied by a player on stage, occasionally you may need to pull something out of the hat yourself. Some chorusing on a vocal, or the aforementioned synthesizer vocal pitch effect. Depending upon the size of your system, you may want to plug in a multi-effects processor in-line on a channel. Or you may have enough aux buses that you can afford to simply use one just for the occasional special effect. Is it worth spending money buying dedicated effects units as opposed to using the effects that might already be built into your mixer? That's a difficult one. And in fact the answer is made even more difficult when you consider digital mixers. If you're running a small rig with a powered mixer like the EMX68S, that will deliver all the reverb and delays and special effects that you're realistically going to need. Plus it has an effects bypass jack so that you can use a foot switch to mute the effect when you don't need it. This is all excellent if you're mixing yourself. Leapfrog up to a medium-priced digital mixer like the O1 V96, and not only have you got 4 super high-quality signal processing effects built in, you can also apply digital compression, limiting and even noise gates on every single channel. Imagine the cost of buying, say, 16 individual pieces of equipment. So this is going to be a massive cost saving. If you're using a more modest featured analog mixing desk, then a top quality dedicated reverb unit can give your sound a coating of quality that makes complete economic sense.